Hello students, today we will learn about the nature of the different oxides. Nature of different oxides. We know that metallic oxides are basic in nature and non-metallic oxides are acidic in nature. So today we will learn how the basic strength and acidic strength changes along a period or along a group. So at first we will discuss about the metallic oxides which are basic. Okay. So at first we will learn about the nature of the metallic oxides. Suppose as we move down along a group, suppose we are moving down in group 1 from up to down. So the first metal is lithium, then sodium, then potassium. Okay, so lithium will form lithium oxide, sodium will form sodium oxide, and potassium will form potassium oxide. So what will be the increasing order of the acidic strength of these three oxides? As we move down a group, atomic size of the metals decreases. Atomic size decreases. As the atomic size decreases, basic strength of the oxide increases. Okay, so as we move down the group, atomic size decreases and basic strength of the oxides increases. So the increasing order of basic strength of these three oxide will be Li2O less than Na2O less than K2O. Again, for group 2 metals also we can write that magnesium oxide is less basic than calcium oxide and calcium oxide is less basic than strontium oxide. Also, lithium hydroxide is less basic than sodium hydroxide and it is less basic than potassium hydroxide. So moving down a group along a period, acidic basic strength increases. Okay, now we will learn about the non-metallic oxides, nature of the non-metallic oxides. Okay, so suppose we are moving from silicon to phosphorus to sulfur. Okay, so the oxide of silicon will be silicon dioxide SiO2, the oxide of phosphorus will be P2O5 and the oxide of sulfur is SO2. So which one oxide will be most acidic? As we move along a period from left to right, electronegativity increases. What increases? Electronegativity increases. As electronegativity increases, acidic strength increases. Okay, so SO2 is more acidic than P2O5 and P2O5 is more acidic than SiO2. Okay, similarly we can conclude that HNO3 is more acidic than HPO3, which is more acidic than HSO3, because in group 15 we move down from nitrogen to phosphorus then to arsenic. Electronegativity decreases. So basic strength, sorry, it will be acidic strength. So the acidic strength decreases, but there are some exception. What will be the acidic strength of HF, HCl, HBr and HI? Okay, so what will be the acidic strength of HCl, HBr and HI? The answer will be HI is more acidic than HBr, which is more acidic than HCl, which is more acidic than HF. But we know that as electronegativity decreases, acidic strength decreases. So electronegativity of fluorine is maximum. So HF must be more acidic than HI. But how this happens? We know that the size of the iodine is much larger than the size of bromine, and the atomic size of bromine is larger than chlorine, and the atomic size of fluorine is smaller than chlorine. Okay, so as we move down the group, atomic size increases. So as atomic size increases, the bond between the hydrogen and the halogen becomes weaker due to increase in size. So as the bond becomes weaker, it is easily, the hydrogen atom can easily removed as H plus ion. So as the power of removing H plus ion increases, the acidic strength increases. So HI is more acidic than HF because the bond strength between hydrogen and iodine is weaker compared to HF bond strength due to the large size of chlorine. So also we have to take in consideration that atomic size also affects acidic strength. Thank you.